The Valley Farm Bureau Specialty Crop Hub and Rural Education Program, also known as SHARE, has been formed by Madera, Kings, and Tulare County Farm Bureaus to serve as a regional, innovative network of specialty crop growers in our respective counties. With over 824,000 cumulative acres in specialty crop production and 6,350 farming operations, these areas hold a large demand for demonstration sites that are easily accessible for producers to witness innovative technologies and farming methods at work in our own geographical region. SHARE's mission is to aid interested producers from first inquiry to project adoption and include recruitment of producers to participate at future demonstration sites. Demonstration practices will include advanced irrigation systems with fertigation, sensors and automation, organic nutrient sources and nutrient cycling, soil health projects, various IPM implementation practices, and remote sensing. My name is Christina Beckstead, and I'm here today representing Madera County Farm Bureau, Kings County Farm Bureau, and Tulare County Farm Bureau, as well as partnering with Chowchilla Madera RCD as we bring to you a presentation on cover crops in the orchard. We'll be in the field today with two growers, one just outside of Stratford, Jared Barba with Stone Land Company, and one in Madera, Justin Wiley with Wiley Farms Ranch Management. As we go through the orchards today, we're going to talk to you about the benefits of cover crops, as well as some of the practices that have been instilled on these various farms. We hope you enjoy the presentation today.
My name is Jared Barba. I'm from Stone Land Company. I'm a PCA CCA over here, and I've been here for 9 years now. What made me decide to become a PCA was that I had a degree in biology, and I had no idea what to do with it because I didn't want to keep going to be in med school or any of that. I got kind of burnt out, and I was like, well, I've always liked farming. The most rewarding aspect of what I do is I think it's getting to be out there with other people that are like-minded. The farming community is very accepting. It's not as cutthroat, say, as other industries where people don't want to share information. People don't want to tell you stuff. Like, if you need a helping hand, farmers typically help each other. That's just how it is. And you be at the coffee shop, you be at the donut shop, be at a UC meeting. It's kind of more of a community. I enjoy that part about it.
My name's Justin Wiley. I grew up in ag. Came back to the family business, the ranch management business and farming business in 2008. I farm pistachios, citrus, almonds, and on the ranch management side, we also farm pomegranates. We've been using cover crops consistently for about 6 years now. So in this field, we started out with cover crops a few years ago as part of the Healthy Soils program. This field is certified organic, and this fall will be my first organic harvest. My goal in this orchard, there's several things. The sun heats the soil up in direct sunlight, up to about 140 degrees. With a dried cover crop, we've noticed, I have a temperature gun that I keep in my truck, we've noticed that even with dried ground cover, in 105 degree heat, you will have a ground temperature of somewhere around 95 degrees. And that's if you have perfectly dried, dead ground cover. If you have live green growing ground cover, that 105 degree heat, your soil temperature will be 85 degrees or even less. If it's obviously in the sprinkler pattern, you're going to get even more of a cooling effect. The vast majority of your soil microbes are alive in the top 6 inches. If you allow your soil to be baked in 105 degree heat in the middle of the summer, you are essentially either causing those microbes to go dormant or die off. And so the goal here for me to provide year-round ground cover first is to improve the microbial life of the soils. Last year when I established the permanent ground cover, one of the first things to come up, much to my family's disappointment, was a lot of fleabane and mare's tail. So I took a lot of crap from my family because they had to drive by the ranch and see a lot of mare's tail, a lot of malva, a lot of fleabane that was just completely unchecked and out of control. What was really interesting about it though is that based on Elaine Ingham and watching her lectures on soil succession, is that when you have a lot of nitrates that are available in the soil, you're going to get a lot of those early successional plants that come in, and that is a mare's tail and a fleabane type. As that nitrate gets depleted in your soils with the permanent ground cover, you will actually start to see those plants die off. And I did. In the first year, I saw my malva with fungal disease. I saw fleabane getting attacked by aphids. I continually see that in the field now, where I'll have weeds that pop up. And what's happening over time is, as those nitrates are depleted, I'm not applying a lot of nitrate in season or any. I'm doing mostly compost to meet the nitrogen needs of the plant. When you don't have those nitrates available, a lot of your weed species will naturally die out, and that soil will go on a natural succession and start propagating different seeds.
Well, with the organic farming, you need to have something on the surface growing. So when we're growing organic, you can't have a whole barren field. That's just not how organic works. You need to have some type of native, well, for planting back into native species. And then we have stuff growing there and flowering. Well, that increases the pollinators. If I was going to start, I would make sure I have a soil test. That's the most important in farming in general. That way you know exactly what your soil is. That's kind of number one farming in general. So if you do that, and you give that to your seed guy, he's going to be able to say, okay, well, that's not going to grow there. I know this isn't going to grow, or this is going to grow really good. The benefits are astounding, especially on our row crops. You can really see it, like in, say, we have an area with a heavy clay soil, and that field is very, very rough. I mean, you don't see biodiversity in there. It's like rocks. When you come through with the cover crop, you see wildlife in there. You see there's roots, there's porous holes. I mean, sometimes it used to crack and you can drop your phone in there and you'd lose it. Well, now it's a lot more uniform, and it really, really keeps them porous, and it really can accept the water a lot better. Your water's actually going down instead of pooling on top, and you can actually get equipment through there because it's actually going through the surface layer of the soil. So you're getting penetration. Well, we weren't getting penetration before. It was just sit there on top, and you just have to wait. And it was kind of a pain to get it wrong with the rest of the practices of farming. It's effective on its own, but it's just like anything. It's more synergistic if you add compost, if you add gypsum all together. It's gonna do nothing but benefit. Typically, we also run sulfur burners, so that's gonna even help more for the penetration. And so I mean, it's not a one-trick pony. You have to do everything to make it all work in one if you really want to see results. The cover crop's best at just sucking up everything that's in there. So if you have excess water in the soil surface, if you have excess nitrogen, anything like that, it's going to use that up. So that way you don't have to worry about it leaching. There's a lot less problems with that because you're going to use it pretty much to grow your cover crop. So there's no downsave when olden times when we just have it all bedded up, and if there has excess nitrogen, then that's going to go down. Well, now we're putting a cover crop in, it's going to help out. So typically that's why we follow tomato fields, whereas we used to use, well, cotton's also very good at absorbing extra nutrients. So that's why instead of just having to only cotton to be able to do that, we could add all these other cover crops too that can also do the same thing.
I've seen a huge transition already. As I saw that transition of increased fungal activity in the soils, I saw more life. So our microarthropods, our arthropods, the sow bugs and things like that are coming in and actually helping me break up organic matter. So just lots of changes that are happening in the orchard. So the point of the ground cover is not only for just habitat for the bees, habitat for the predators that are in the field to try and create some sort of an ecosystem in this field to help me deal with pest issues naturally and not have to spray for them. So there's a lot of reasons. And another reason on top of that would be that as you get roots that come in, even weeds that come in, and they come in with deep tap roots and they dig down, they break up the soil, they provide aeration in the soil, then they die and they leave a pore space there. So over time, what I can see are very highly compacted soils. I have a pintrometer I use all over our ranches. Almost immediately within the top 2-3 inches, I'm in the red on my reading. So very highly compacted soils, even in the tree row. Over time, what I'm starting to see is those soils loosen up. Not only will that provide water holding capacity, it's going to allow the nitrogen cycle, the carbon cycle to come back in my soils, so that my soils can breathe naturally like they were meant to do when they have that full ground cover. And then I'm also feeding those microbes with all the permanent ground cover, the different varieties. And so there's a lot of goals that I have out here, and that's it's going to happen over time.
Once you get going in cover crops, you won't stop. It's kind of something that you see the benefit instantly, and maybe not instantly, but you'll see it in year one. You're like, whoa, I mean, I've had bad water penetration in this corner of this field. all of a sudden you don't have that pulling. You're like, oh, I wonder, or maybe pulling a little bit less. And then year after year, you can kind of keep track of that and say, hey man, my soil's changing a little bit. It's a lot different now. I mean, I'm porous, especially for tree crops like pistachios. They're not typically planted on the greatest ground, so they don't like the greatest ground. So when you plant them on these marginal soils, it really helps for water penetration because typically they're alkali or sodic soils. So it really helps out if you use the right mix of cover crop in those soils, that it would benefit everybody in general. So typically, I like working with cover crops because, there's wildlife everywhere. It's just a lot more interesting because, it's aesthetically pleasing. It might be a little bit extra work, but the benefits outweigh the extra work.
If we're just isolating cover crops and speaking about the expenses, the cultural expenses and the cost of managing it, it really depends on your operation. I think because of conditioners and almonds, for instance, there are a lot more opportunities. It's when I look at it from a conventional system and I isolate the cover crops by themselves, there are absolutely benefits. In our orchards where the berms are clean and we still allow a little bit of cover crop to grow right along the berms and just mow a couple times a year where we have drip and just mow over the drip lines, we didn't use a drop more water even in that case. So you have better water penetration. You have a little bit of actual cover where you're mulching some of the green growth during the season because it's going to be warm and it's going to get 89 degrees, perfect growing weather. So you're going to get a lot of growth out of the oats or whatever's there. And just mowing it during the year, keeping it alive has actually been helpful because, as I mentioned before, you'll see a lot of puddling on those drip lines. We saw none of that. So that's the very low-hanging fruit is just water penetration and a little bit and keeping that soil cool so that it's able to actually get down to where the roots are instead of evaporating off.
The most biodiverse thing we see in our cover crops is that the earthworms. If the earthworms are there, they're burrowing, they're going through. We're capturing extra nutrients. We're creating pores throughout the water, or pores throughout the soil, which helps out a lot for water use. And really, you'll see birds, you'll see all sorts of things just flocking all in there, and it's very interesting. In pistachios, with a cover crop, another benefit you have is the chill hours, because you're going to reduce your temperature slightly. It's not a giant reduction, but if it can get you 1 or 2 chill portions and you're just on the line, that can go from having a 500-pound crop to a 4,000-pound crop. There's just such a big jump from those lacking of chill portions. With cover cropping, that's kind of what they're talking about. They want to get the carbon market and you can make the farmers money. Well, if you have cover crop in there, that's going to be a second cycle. So that's going to be more CO2 absorbed, more tons, so you get paid more. But we got to still kind of figure out the market and how that's going to work out. But in the long run, I think it's going to play a big effect on how much cover crop is going to be valued even more to the actual farmer, and actually monetarily valuable.
Lately, because we've been getting later and later rains, we'll time that depending on the crop. In the pistachio crops, we're doing it right now in about 800 acres.
Well, we cover crop in both row crops and tree crops now, and pistachios is one of our main ones that we do row crops or tree crops in, and then we do a lot with tomatoes. So, like if we go from year one, like tomatoes, we don't like to plant tomatoes back to back for disease issues, so we tend to put a cover crop in. We can find out that we can go back to back without having to slow down or do anything of that nature. Well, we typically put, I'd say about the row crops, we usually do about 1,500 acres, which is about, 8%, something like that. Whereas to cover, like our pistachios, 100% get them. Every single tree gets cover crops now. That's kind of been, even our pomegranates, they're getting cover crops. It's just been a different way of, it's come part of our practice of managing them now. That's kind of how we're doing it now.
I think the white clovers, the peas and the beans do really well in our fields in the pistachios for some reason. In fact, a lot of what you see in this field are actually volunteers that went to seed, weren't ever terminated, and then came back prior to me even planting this year's cover crop.
Typically in almonds, we'll do it, if non-independence varieties, we'll do it in the first year or two, because you're still working on getting that orchard floor nice and smooth. So if you have a little bit of time, you got a couple of years to work them in. Whereas where independence, year 2, you're going to have a crop. So you need to get with the program pretty quick. So non-independence trees, we will do it in the first 2 years. Pistachios, typically the first year or two, we don't do it because pistachios are a lot slower growing and they can be out-competed by some of these cover crops. So we kind of like to let it go at least a year or two before we start going. The only species that it can be a problem are like the tubers and the corms. Sometimes they're just hard to kill. They don't want to go down. And when we're doing something we're trying not to use Roundup, it makes it even more tough. So we need something systemic. We had to spray a cover crop before 2 or 3 times and it still not go down. It's just, you got to be able to work with your system that you're in. So when we're doing regenerative ag, we know we can't use Roundup. So then we kind of got to work to incorporate it to make it work. Some cover crops, and you put an alkali acidic soil, if you have 18 species, you might get 10 that actually grow. Some just don't like it, and there's no ifs, ands, or buts about it. They just won't grow in that. So you have to kind of conjure your mix a little bit to make sure everything's alkali friendly or sodic friendly, depending on what type of soil you're working with.
As far as species I need to avoid in the cover crop, I have not run into that yet. I would say there are some problematic native species that I've run into. So in young orchards, if you're doing full ground cover, I would say that Bermuda is a problem. I have that a little bit in this field, but these trees are mature and established. If you're trying to do full ground cover in younger blocks, which is a whole nother challenge in and of itself, but there are a few. Bermuda would be a problem. Johnson grass, some of those things where normally mare's tail and prickly lettuce and fleabane and some of the normal weeds, malva, that I had out in this field, I was perfectly willing to just let them kind of cycle through. And a lot of them have died off naturally and gone away on their own. When you're doing permanent ground cover, perennial ground cover, there are a few different species I would say you need to watch very carefully.
Typically for the row crops, it's a multi-species cover crop. I think our last one was 18 different species. And that one is a little more difficult to manage because it's kind of all over the place. So you can have, maybe your grasses will grow, but maybe the radishes will stay low and then they'll kind of compete. So it all depends on weather too. Weather issues could be a big problem. But so you kind of got to judge what the weather is going to look like too, because it kind of helps out a lot. Well, we've tried it in pistachios where we typically planted triticale for the most part as our cover crop. And we tried to leave it year round, but it kind of gets a little hairy here and there, and it doesn't look as pretty. So that's kind of where it breaks down too. But we've been doing a multi-species cover crop in more of our tougher grounds, like our alkali soils and those sort of type of harder soils to deal with. And they're a different type of mix, so they're more specific to an alkali soil. So that's kind of been our new little project, is messing with those type of mixes.
So our goal in the number of species we use is variety. So part of our purpose here is to change the microbiome of the soil, and the reason for that, there's a lot of reasons, but as far as the variety choices in that, the more varieties the better. So the more unique root exudates coming out of the different cover crops, the better. So we're going to choose as many as possible depending on the year, depending on what seed is available and what our other goals are, but generally we're not going anything less than 6 or 7 different species. Our main goal in the mix is that 24-to-1 carbon to nitrogen ratios. We're looking for ground cover. We're looking for protection of our soils that will last hopefully through the summers. Most of our blocks are not like this, where we're actually allowing cover crop on the berms. So if you're planting in the middle and part of your goal is, soil erosion, if it's been terminated and you have late rains, if your goal is to just keep protection on your soils, if you're going too many legumes and you have a very low carbon to nitrogen ratio, you could be in trouble, meaning that the soil microbes will break down that cover crop very quickly. You'll be left with bare soil pretty early on in the season. So for us, we're not really worried about it soaking up too much nitrogen. We'll generally go with some grasses, predominantly grasses that would be higher carbon to nitrogen ratios, so that it lasts longer in the season, provides that protection for the soil.
We haven't had an increase in pest pressure with cover crops. It's just not been, I just haven't seen it. It could be there. I mean, there could be plant bugs living in there, but it's just the timing's it's all important to have the timing. I mean, you don't want a bunch of seed heads out there when you're just getting your pistachios, say, to size, or they're just starting to become actual nuts. I mean, then you can start having multi-problems. So what we do is we typically mow it if we're going to keep it in there.
Definitely seeing, I definitely see aphid issues. So this is a pistachio, so it's unique in that we are pretty clear on what our issues are, what our threats are. So when I see an aphid in a pistachio field, I couldn't care less. If I had aphids eating weeds in a citrus orchard, in a citrus field, I'd be really concerned, because they'll transfer right onto the trees, and then, the minute you do, you turn around and you could have ant issues and all the rest of it. So I have not. I think the plant bug is the main thing. I do have overwintering of plant bugs. I do see the stings in the fall, in the spring, around the time we're supposed to spray. I am waiting to see whether on a several year basis in a row we can get away with not spraying for plant bug without seeing actual crop damage. And what I see, and it's a chicken and egg argument, what I see with the plant bug, the small plant bug, Calcorus, some of those, I don't have leaf footer over here in Madera. They may be in parts of Madera, they're not in this area, where they're actually stinging the rachis and the entire cluster is going down. I'm seeing minimal amounts of stings, and in some cases when you cut the nut open, you're actually seeing a nut that had already aborted wasn't going to grow anyways. It's hard to determine whether or not the sting aborted the nut. In some cases that's obvious. In some cases it looks like the outside of the nut was just blackened, but the nut wasn't going to grow anyways. So it's hard to know which came first in that situation. But my theory is that if there are stages of plant health, and then at the higher end stages, you've basically crossed a threshold with your plant where the plant can resist almost any pest or pathogen out there. There's a few exceptions, locusts, for instance, and some of the bigger pests, but for the vast majority, especially when you're talking about sap-sucking insects, we should be able to get our plants, our trees, to a level of health that they can resist the vast majority of attacks. Plants have been known to respond. They release secondary plant metabolites to try and discourage being eaten. They're not helpless. We just need to give them the right tools, put them in a position where they're not stressed to the point where they can't defend themselves.
We like to plant our cover crops in the pistachios, especially like right around this time. So December or November, December, let it get over the wintering time. So we get a little bit of rain. We're not watering right now, so it gives it enough to kind of get itself started. And then by the time we actually irrigate, like say in February or March, it's already got a little bit going, a little bit of heat. And then once the heat starts coming up, like the actual temperature heat, then we water it, and you'll get a nice little stand, and it really works itself in, especially the triticale. The triticale works really well because it grows up, and I mean, we plant winter wheat as well, and we don't have to put much water on it. It's kind of almost like dryland farming wheat. We typically go in at field capacity, so go into the winter, like when our winter break. So we make sure that we're at 100%, and especially with like the rain that we were getting recently, that really helps out a lot. It really keeps the soil moist enough to where it can germinate. It's really important. If you're planting a cover crop, it's in between pistachio trees, so you don't know how much that pistachio tree is using as opposed to that cover crop, especially because we're planting in the middle of the rows, so our drip lines are on the tree rows, so those are 4 or 5 feet away. So you'd take 48-hour shot of water to get that water to go down to the middles, if at all. So really, it's kind of hard to decide what it actually is.
As far as how much water the cover crops are using, I have some pretty strong opinions about that because we're going through that in Madera right now. So in this ranch, in a normal year, if I were to get 12 to 14 inches of rainfall, there's a good chance the majority of the water that hits the ground here is going to run off. It's going to take my topsoil with it, with no cover crop. That water is not going to be counted for us as growers as far as our total usage for the year. The water that's running down my roads and into my neighbor and out Root Creek and out to the ocean is not going to be counted in as far as my usage. What we're being told is that the ground cover that I have, because it's transpiring, is going to be counted for that. So no one is out here measuring the runoff in some of these fields. When we get 2 or 3 inches in one giant storm, we are being measured for the transpiration. And so my argument is, yes, this is using water. When it is 105 degrees out and your soil on the berms heats to 140 degrees because it's bare, and that reverse capillary action happens and water is being wicked out from 6 inches down, so that the next time you irrigate, you need to rehydrate the top foot of your soil in order to get that water to your roots. You are using as much water as my cover crop is trying to keep the soil at 85 degrees because that reverse capillary action is not happening in my fields. So This has been proven in several different studies that overall cover crops do not use more water than bare soil. If you want to include the fact that our soils are compacted, they're not able to take in the water as we get it during the winter and hold it. If you also want to include the fact that they will compact, we're losing our microaggregates. Essentially the glues of the soil are going away because the exudates that are coming from our trees are not varied enough to support the microbial life in our soils. Without the fungi, without the mycorrhizal, without the bacteria populations that we need to flourish in our soils, the microaggregates go away. Essentially, our soils pancake. When they pancake, they flatten. They're not able to take water, and when that happens, they're not able to breathe. So the water holding capacity gets greatly diminished. And so, in a normal wet year at 12 to 14 inches, if I'm able to restore the soil aggregates into the soil and reduce the compaction, along with all the other life that's out there, the beetles and the worms that are creating pore spaces in my soils, the microarthropods, I am going to have double or triple the water holding capacity of someone that's done nothing. And so in the short term, there may be an argument for slightly more usage. I doubt it with a cover crop versus completely bare soils. But here's the point. Long term, in 5 years or 10 years from now, if I'm able to get my soil, so in 1 year, I went from about 0.25% organic matter in these soils. I'm now at about 0.9% as of my last test in November. I expect by the end of this year, it will start exponentially increasing because the first thing you need to do to improve microbial life is to reduce salts. So my attempt is to not lose the production on the ranch, but not use high salt index fertilizers at the same time. But once you reduce the salt load, you're able to see that microbial life take off. And once the microbial life takes off, you can start to see exponential increases in your soil organic matter. Once your soil organic matter increases, the studies that have shown a 1% increase in soil organic matter equals 25,000 gallons of water holding capacity per acre. If they haven't been heavily grazed or fertilized for years or tilled, you can see up to 7, 8, 9% organic matter. There are places in the Midwest that get more rain than we do that are up to 20% organic matter. So you can do the math to see if I'm able to succeed here and increase the soil organic matter over the next 10 years, my water holding capacity could actually provide me enough holding capacity to cut my irrigation by half. Personally, I found there's no need to fertilize. If you're having to fertilize for a cover crop, unless you're planning to harvest it and you're doing some sort of double cropping, there's really no need to add fertilizer in my situation because of my long-term goals. As far as sanitation in our fields, we do annual sanitation. In most of our blocks, we blow the berms and then we'll use a flail mower to come through and break up the mummies. Sometimes we're doing multiple passes to try, if we get an early rain where they're stuck on the berms, it takes a couple passes. We've even brought in sweepers from some local almond harvesters that weren't busy, where we bring in a sweeper and try to, put them in a windrow so that we can get to them easier when we come in with the flail. So that's the standard practice. Out here, what we've gone to is high fungal compost teas. When you have ground cover, I don't think this would work when your berms are bare, but when you have ground cover, that moisture is going to hold. And so if you do have any rain early on, and once you've been through and pruned the orchard and the nuts are out of the tree and on the ground, if you can get in there early enough with a high fungal compost tea and reintroduce some of that biology, if your salt load has started to go down where you do have more microbial activity, you will see a lot of those nuts by the springtime have rotted out. They've either molded, there's other bugs in there, there's other arthropods that are in there eating away at them. Permanent crops, trees, deciduous forests, and then eventually coniferous forests, they have fungal to bacteria ratios of up to 500 to 1. At the very least in our orchards, we need about a 5 to 1 to a 50 to 1 fungal to bacteria ratios. If you're growing row crops, vegetable crops, things like that, brassicas, you're okay to have a much higher bacterial population in your soil. In fact, your crops are going to thrive under that circumstances. In permanent crops, we're aiming for high fungal ratios. We want that relationship that mycorrhiza can form with our trees. So on several fronts. Mycorrhiza, when you start to get rid of the salt content in your soil and drop the salt content that inhibits microbial growth, once you bring back that mycorrhizal population, you are going to increase your root mass by up to 20 times. So mycorrhiza can form a symbiotic relationship with your roots. Then it can increase the root coverage period. It can fit into pore spaces in your soil that your roots of your trees cannot. So it can extract water that would normally not be available to your trees. It can help transport solubilizing phosphorus and nitrogen bacteria and transport them to the rhizosphere next to your tree roots so that it can actually trade photosynthetic sugar. So it's going to help feed your trees. This is essentially a high fungal compost full of mycorrhiza, full of protozoa, and full of predator nematodes. What we're trying to do as we're lowering the salt content of our soils is reintroduce the mycorrhiza, reintroduce protozoas, protists back into the soil, try to get some of the microarthropods out there cycling some of the organic matter. So as the microarthropods and arthropods, earthworms break down dying and dead leaves that are on the soil surface, they're actually releasing some of the nutrients that are tied up in those. You'll notice in a conventional system, sometimes we'll have leaves on the berm that are 6 or 12 months old. So in other words, there's no microbial life there to break down the organic matter that's falling onto the surface of our soils. So what we're doing here is, that's the first step. The second step is that as a pistachio grower and almond grower, we are always afraid of alternaria. We're always afraid of botchophoria or bud strikes during bloom. So fungal issues in pistachios, as we have to pour on the irrigation during nut fill, can become a major problem. You have high humidity. You have a tree that's stressed because you have a crop load on it, and it's sort of a recipe for disaster. There's a lot of orchards now that are pre-treating for alternaria, for instance, as part of their program. 20, 30 years ago, that wasn't a standard part of our program. High fungal compost teas, when you introduce a lot of microbes back into the system, especially those systems that have been sterile for so long, we've been trying to sterilize everything to remove all of those threats to our crop so we can bring in a high quality and clean crop. This is going the other direction. So what I'm doing here is the same type of premise. Is we are going out with these fungal teas several times during the year. We're introducing biology into the system, a mix of biology, with the hope that we're going to outcompete some of the alternaria and some of the issues. This block in particular had a really bad alternaria several years ago. It's not gone completely, but what I've seen is that every year I'm shrinking that footprint. It spreads a little bit, it will stay isolated. So not only am I introducing the competition, at the same time, I'm focused on improving the health of my trees by sap sampling and determining what I need, and then also improving that relationship with the soil so that I get rid of that hidden hunger that a lot of our trees have. And as there's a lot of research out there that says that the vast majority of the disease issues and the pest issues that we have in our permanent crops and our row crops is a result of some sort of nutrient deficiency. We need to take advantage of what's already in our soil, and in a lot of cases there are enough nutrients in our soil for us to farm for 100 years and never deplete what's already there. What we need to do is find a way to be able to make it soluble and improve that soil relationship with our trees so that our trees can access what's already there. But the vast majority of the compost, all of the compost that I'm applying here as part of the Healthy Soils program is purchased from a third party. We are buying high fungal compost. It's very expensive from a local company. And then we're using that in our compost teas because a little bit of that compost goes a long way for compost teas. And then we're also now starting to do our own compost, inoculate it ourselves, and then track that progress. The main parts for our compost tea, if you're trying to promote fungus, high fungal, is oatmeal, fish hydrolysate, a kelp, and a humic acid. And so those are the main components. Oatmeal is optional. A lot of times if you leave the oatmeal out or you leave another fungal food out, you'll end up tipping the scales, and the final product, the tea that you brew after 24 to 48 hours of brewing, will end up higher bacteria ratios than what you started with. So we add oatmeal in order to continue to tip that scale towards high fungal populations. But generally you're going to have some sort of kelp, a fish hydrolysate, and a humic as sort of the house for the microbes to live in, and then we add the oatmeal. So as far as tea applications directly to the soil, we've gone to compost tea applications in lieu of sanitation, in lieu of scraping our soils, creating dust clouds in December and January, and then let me start by saying that sanitation, as far as I'm concerned, especially for the pistachio industry, is an absolute silver bullet. If we can reduce the food source or eliminate the food source in our orchards, you will see an immediate reduction in the orangeworm damage in your crop. So I mean, I think every pistachio grower knows that. We're trying to get away from having to scrape our soils, and you know, obviously we're all dealing with dust issues, and you know, I think we're all under pressure to try and do what we can there. I know the almond board is looking at that. in this case, we are trying to apply high fungal compost teas in order to improve the breakdown of the food source during the winter. And we can go out into the field and I can show you a lot of mummies that are, have a lot of white mold on them that are breaking down, and there's almost nothing left. So if you can get it out of the tree, and this is common knowledge, but the damage you'll see from a mummy sitting in the tree for the season and attracting navel orangeworm because it's a rotting a kernel in that nut, versus being in the ground where there's opportunity for the arthropods to break it down, or mold to get in there and it can hold its moisture better and potentially break down, is night and day. Compost teas will very, very quickly go anaerobic if you're not introducing enough air. So the microbes that we're trying to foster are aerobic microbes. Those are the healthy ones. Obviously, we fight water penetration and cutting off our roots from air when we're trying to irrigate and keep our crops irrigated, especially during the hottest part of the season. And when you get anaerobic conditions, that's when you start to see root health decline and phytophthora issues and everything else. So we have a compressor that's blowing air into this. When you're doing a compost tea, we tried to build this ourselves and do other, I've seen setups where they're doing a little bit of a fish bubbler and you have a few bubbles kind of aerating through. What we're seeing in those conditions is that it's gone anaerobic already in that. Within a few hours it will go anaerobic. So once we stop this compressor here, we have about 2 to 3 hours to use it before it goes anaerobic. It happens very, very quickly. So it's about a 24 to 48 hour brew time. Usually you don't want to brew more than about 3 days unless you're introducing more food source, more compost, and more fish hydrolysate. So that's it. It's a fish hydrolysate, kelp, 24-hour brew time, and that's about 300 gallons. And so we'll apply about 20 gallons an acre. So that gets our one sprayer, gives it about an 8 hours worth of spray. We have a root creek that flows through the middle of this ranch. It's a pretty large drain. Over here is some cow ground, just open ground, open pastures that they graze. And as anyone knows, we're getting these atmospheric rivers that come through, and our 12 to 14 inch average, it hasn't been that the last few years, but even this year our 5 inch or 6 inches that we got came in 2 or 3 big storms. And so when that happens, and you have ground that lacks pore space, it lacks structure, it lacks micro aggregates to take the water, essentially we're lacking water penetration in our soils, even in the cow ground, even in the open ground. What we're seeing is that when you get an inch or two in a storm, that root creek is going to flow. And it's amazing to see ground that is just open and grazed, releasing the amount of topsoil that's coming through that open ground into this root creek and flowing out. And I actually have at the bottom of this root creek, it's just grass. It's some Bermuda, some other grasses that go dormant in the winter. And a lot of that soil is actually being deposited into my field because it's trying to hold it. And then it's not perfectly clean when it leaves the field, but you can see if you stand on one side watching the chocolate milk water coming out of this open field, and then standing on the other side where it's gone through active grass, you can actually see it's depositing some of the dirt and leaving it here. So, and that is a big bonus for this field because obviously I'm dealing with a lot of hilly ground. You can see it in my roads and whatever else after a storm that water is going to pick up very quickly in this field and run off. And so just one more benefit of keeping permanent ground cover.
It's something you plan for. So if you really want to do a cover crop, you just got to know what you're working with. So you're not going to want to plant something that grows tall, for instance, if you have little trees. If you have a bigger tree, then you can kind of mess with it a little bit more and let it grow a little bit. And then you just got to figure out when you want to terminate it. Like if you want to work the ground, if you want to incorporate it, you got to figure out all those things ahead of time and know your varieties you're planting. Because if you plant something you have no idea, say you planted greater sunflowers instead of lesser sunflowers, well, you're going to have giant sunflowers in your field that you got to have to deal with later. It's just every time you put something new, you're going to have to think about what's it going to do, what's growing. Is it going to move around? Are you going to spread seeds everywhere that you don't want? It's something you got to think about ahead of time. It's just not something that you just go willy-nilly and put out there. I mean, if you just start slow, it works a little bit better than just trying to throw the whole gambit out there and just, all right, well, I'm going to put 25 species and they all look good. It doesn't work that way. You have to kind of know your soils, know your area, kind of know what your weather is going to look like, more or less, and go from there. You don't want to be planting summer and winters and that sort of thing.
So far in the last 2 years, other than splitting a tree during harvest where they didn't pull the arms back and drove forward and basically uprooted a tree, I've only lost one tree in the whole orchard. In this block and the other blocks, so there's about 7,000 trees on this block, I've lost one tree. So I do think there are some challenges there as far as ground squirrels and gophers. It's going to be an ongoing battle. But you know, when you compare my orchards where I'm not using a fungicide ever, I'm not using a herbicide ever, and some of those budgets I know very well can run, you know, $400 an acre plus annually for herbicide, you know, $200 to $300 for fungicides. My insecticides consist of, you know, once a year a beneficial nematode spray to try and attack the eggs that are out here. The vast majority of the mummies that are in the field, because I'm spraying compost teas on the berms, are breaking down in the winter, especially when we get a little bit more rain. There's more moisture out there, but if you dig in under some of the leaves and the grasses, you'll actually, it's pretty moist there, and what you'll see is that a lot of the mummies are breaking down and rotting out. And we don't see that in our conventional systems. Those mummies can sit on the berms for years and just be a food source during the flights of the navel orangeworm for multiple years in a row. Regenerative agriculture and organic agriculture are not without its challenges. Overall though, my budget is far below what you'd see in a normal conventional system, even having to use some organic chemistries to deal with deficiencies. There are some challenges as far as the timing of your cultural activities. The main thing for us is it depends on what kind of early rains we're going to get. If we do get early rains and we've already planted, especially an annual cover crop, you know, with an oat and the vetch, you're going to get a lot of early growth most of the time before you've had a chance for the trees to go dormant and get in there and prune. I would say that's the biggest challenge, is if we do have a year where there are early rains, then you're trying to get in here. You can't mow with a flail and break up some of the larger branches. You need to bring in a shredder, and when you bring in a shredder and you have too much green material, obviously growers know that it's a mess. So that adds a little bit of cost, where we're either having to try to mow prior and knock down that cover crop a little bit on some blocks, and then get in there and shred real quick before the cover crop comes back up if we're getting more rains. So that's one of the biggest challenges in California, is that we have these, you know, gaps in the middle of the winter and potentially warm weather where you can see a cover crop actually die back before you get the next rain. So the healthy soils makes that much less risky, because they're helping to foot some of the bill. As far as my cover crops out competing the permanent crops in my orchards, I have seen issues in younger trees. So this area that we're standing here is a younger part of the field. It was planted several years after the rest of the field. So even during the summers, when we have a full canopy, you have a lot more light penetration in here. So even though you may have full canopy on a good percentage of the berms, you know, the way the sun comes across, you have almost full sun on these berms all day long. So that's kind of an interesting nuance, is that when you have a little bit of younger trees, you're going to get some different species coming in here with full sun. And even as we're applying more water in these younger trees during the summer, we'll actually see the clover and some of that actually start to get really aggressive and come up higher. So it does change the management a little bit. What we did in this field is actually just close the risers a little bit to cut off some of the water so that we weren't overwatering in this part of the field. We actually started to see some species of plants come up that we didn't want to see: vinegar weed, Jimson weed, and things like that. So usually the result of compaction, but also a combination of waterlogging and compaction. And so that's a nuance with this field. I think when you do have full sun, you get a lot more light penetration. You do have to be concerned about certain species. So for instance, even in the rest of the field, we had a lot of prickly lettuce, and prickly lettuce will grow 6 to 8 feet tall, especially if you're early on in your succession and you have a lot of nitrates in the ground. That prickly lettuce is just going to go. And so that was something we had to come through and clean up. But at the end of the day, I'm going through these fields annually, once a year generally, with weed eaters. We'll either mow if we can. We have some mowers on some flail mowers on articulating arms that can get under the trees if we need to. As those branches come down and the crop gets heavier in the pistachios, we can get under the trees. But generally it's not bad enough. We're spot treating, where I'll probably spend somewhere around $30 an acre right before harvest just to get in here and clean up some of the curly dock and some of the prickly lettuce that comes up and tends to get in the way. And that's generally because we're bringing in third-party harvesters. They've never seen anything like this before. In a truly natural system where we're not high intensity farming, where we're trying to make a living out here, you could let the field go to voles and ground squirrels and whatever else. If you weren't grazing or doing anything else over time, it would clean itself up. You'd have a natural ecosystem. We can't do that here. I can't allow a vertebrate population. I'd start losing trees, and I've only lost one tree in the last 3 years, but it is something we're having to deal with and treat. I'm paying a lot of attention out here. I'm out here walking the field and just taking a walk around the field as much as I possibly can, just because I want to see what's going on and see some of the new species that are coming in and what problems that might bring. There's a lot of traditional knowledge around having cover crops or in general ground cover underneath our trees that has been said traditionally is problematic, and so it can create pest issues, it can create more disease issues, keeps the field more humid, for instance, so you might see more fungal issues. So I'm watching all of that. I haven't experienced that myself. If anything, I'm hoping that the Alternaria is getting better every year. It looks to me like it is. I haven't seen the issues around bloom. I haven't seen increased plant bug issues. I definitely have stings out here in the nuts, but I haven't seen a drop in production as a result of that. And there's a field we're doing it on nearby that has done nothing but increase in production. It's a very old Atlantica block, been very consistent for 15, 20 years. We've actually seen a little bit of a bump in production the last few years. So I'm assuming some of those trees are actually doing better under this system than they were prior. So but like I said, it's not without its challenges. We tried to graze the ranch with sheep, left them in too long. They basically grazed everything all the way to the ground. We didn't rotate them quickly enough, and after that, when we started irrigating again, we just saw an explosion. The weeds come right back through, and it's like, well, this is spinning our wheels. What's the point of doing this and grazing it just to recycle all the green matter that's out here and get the nitrogen boost, only to have to fight the weeds again right away? So, I think if you're going to do grazing, for instance, you don't want them eating all the way to the ground. You want to keep as much ground cover. There's actually vitamins in the saliva of cows that when they bite into a grass, they're providing vitamins to that grass, and it'll actually stimulate the growth. And so there's a synergistic system here. If you are going to actually introduce grazing, it's going to be a lot easier in a pistachio. They don't want to browse the trees as much. It'd be probably okay to some degree in a citrus orchard mature, but there's just a lot of challenges here in what we're trying to do, and a lot of questions we haven't answered.
Incentives can be a big push to have people get started in the program. And once I think people get started, they get used to it, and I think that's going to be a major driving factor for smaller farmers that need that little extra boost to get them to think about, like, hey, is $100 an acre going to be worth it? Is it going to pay off in the end? I mean, do I need to do this? That's kind of the main thing. So if you have government grants that can help you with this, it really will change how you're thinking, your thought process.
So I applied for Healthy Soils. I think that's a great program. Healthy Soils is a program through the state, CDFA, California Department of Food and Ag. And through Healthy Soils, you can apply to get funding for cover crops, reduction in nitrogen. You can apply for not doing any tillage. And then in my case, so there's nuances there. There's a lot of parts of the program, but my specific contract was for compost, an elimination of tillage, a reduction in nitrogen, and then also cover crops as well. For small growers, it's a fantastic program. Getting started with eliminating your nitrogen and putting on, so in this field, the last 2 years, I'm going into my third year of the contract, I put on 8 tons per acre of compost. Because I'm doing 4 or 5 sap samples per season, we paid really close attention to the nitrogen levels. Sap samples are really interesting because they're going to measure your nitrate levels, your ammonium levels, and then your total nitrogen. And that is a little bit of a difference in when you're looking at soil samples or your nitrogen levels in your tissues, where it's actually measuring nitrates. We want the nitrates gone out of our trees. We want either ammonium levels to stay consistent or total nitrogen to be at a certain level. And depending on the lab you're working with, they have their differences in opinion on what that minimum level is. One of the challenges of sap samples is going to be our normal, what's considered a normal or adequate level for any of the nutrients from phos or potassium, whatever. So that is a challenge, but as far as programs, I think Healthy Soils is fantastic because you are going to get reimbursed for the majority of your inputs as far as seed costs and compost, and then also you can apply for reducing your nitrogen at the same time and actually get funded for that as well. And so it was a great fit for me on these fields as I was transitioning to organic. There were some challenges and some debates going back and forth with the NRCS folks about what I was able to do under my contract and what I'm not able to do. So it really does have to be a good fit for where you're at in your program, but I would recommend it.
Well, in a funded cover crop, the whole point is to increase organic matter. So if we're growing it, we need to incorporate it in. So to do that, we'll have to pretty much shred it and leave it on the ground and then work it into the ground. It can become a problem sometimes. So sometimes you have to terminate it chemically and then incorporate it into the ground. Whereas if it's not non-funded, and well, you can actually fund itself by getting money for the tonnage that you're cutting off the top of it and actually pay for itself. So it's a win-win for everybody. Typically, if you're going to do a funded program, it's about a year ahead. So you got to plan this year's crops and when that's going to end and how it's going to go into the next year crop, because you're not going to want to plant something that's 60 days after. That's not going to work because we typically do 90-day cover crops, and that's what we're used to now. So we need to make sure we have that window, or else you're not going to get much of a benefit out of it because it's not going to grow in full size. We tried a few years where you shred the tops and incorporate into the ground, but it's not working out as it's tough because that's a lot of organic matter on the top of the surface of the soil. So what we'd been doing when we first started, we tried disking it in and working it in, but then we found out that a lot of dairy farmers out here need feed crops or some sort of feed. So we have this. It's actually pretty nutritious, so it's enough for them to pay for. So we've harvested it, and it ends up paying for itself in the long run. Well, we found that if you use Roundup, you might have a little bit more issues for your termination. So you need something that's that's what they say, is that the Roundup causes a little bit of a problem because it, like say the radishes and the other tubers that are in the ground, it'll absorb that. So when it comes to, it's almost like a slow release. So that we found that, maybe we'll try something different. But typically we have to use a burn down of some sort and then work the ground, or else it's just going to be there forever. But typically what we do is we shred them, and then what we like to do is either we shred them one time and then we'll see how they grow back, because they'll just keep growing if you just shred off the tops. And then if it's just not doing very well, then we'll come through and just disc it in the middles and incorporate it into the ground. We've also tried to plant them in almonds, but it's it's pretty sketchy because your almonds need to have a flat, clean surface when we harvest. So the termination of that was very tricky because you really need nothing left. Because if you have a little bit, it's going to mess up you're going to get your almonds stuck in there. It's just it wasn't easy. We planted that at 15 feet across in a 22-foot wide spacing. So that ended up being more of a problem because we had to go in there with Gramoxin and Roundup, and we really had to go after it to knock it down, whereas pistachios, you don't need a clean surface because the nuts never hit the ground. So it's the almonds are a little trickier. But this year, we kind of switched it up a little bit due to the bee health programs. So we planted a 16-acre block a little differently, and we're going to see if that mix will work out a little bit better. That way, it's supposed to have pollen or flowers at bloom time. So that would be kind of important to keep the bees happy. And we're planting that around other orchards of almonds, trying to do like little strips on the outsides and the edges. That way we can satisfy what they need from the bee health people, and we can also have cover crop in that ground. So we don't have to have termination inside the almonds, which can be quite a problem.
So as far as terminating the cover crop in these fields, I don't. In the 3 blocks that I'm transitioning to organic now, we have a couple more to follow this year. We are not terminating the cover crop at all. In most of the pistachio blocks where we do have clean berms and we're just planting cover crops in the middles, there's no need for us to terminate it either. The main consideration with terminating the cover crop is your timing with your plant bug sprays for a pistachio. So it all depends on the spring rain. So if you have a cover crop that's growing really nicely, you've gotten enough spring rain and it's continuing to grow, there's no reason not to leave it.
In organic farming, you have to have non-GMO cover crops. Well, the first few years, or the last 3 years ago or so, you could have a letter that said you didn't need that. Like they couldn't find outsource that seed. Well, they're getting a little more stringent as more seed producers are coming along. So you need to make sure that if there's any inoculants, if there's any GMOs in there, if there's any, you need to have that in your OMRI certificates all lined up so that you know, okay, this is going to work or this is not going to work. Because if you don't, then there's going to be, it's not fun. Organic cover crops are a lot easier to attain. Over the last 3 years, there's been quite a push because we just started organic pistachios about 3 years ago. And you can really see that they're starting to ramp up. Not only organic seeds, but the organic inoculants, which is kind of important. So then we got organic, they're seed treated, but they're organically seed treated. So it all works out better for everybody. Well, in year one, from our first cover cropping with the Healthy Soils program, we went from about a 0.6 to a 1.6. So it was about a 1% increase. That's pretty substantial.
As far as regenerative ag programs, I have not participated in any or received any funding. I would consider myself a regenerative farmer. As I mentioned, I don't use herbicides, fungicides, or insecticides, not even organic ones. So my goals for this orchard long term is to improve the fertility of the soils to the point where I can cut my inputs by somewhere around 60 to 70%. I would still probably come in annually with some compost. I would probably still do some compost tea sprays. I would still probably, through sap sampling, identify, things like boron deficiency. I mean, it's a leachable anion. You're going to have issues where it's going to go through the soil profile. You're going to lose. We don't have boron in our water out here. Pistachios eat boron for breakfast, lunch, and dinner. So there'll always be inputs on this ranch. But I would consider myself a regenerative farmer as far as my goal of trying to improve soil health. And I think what we do in a normal fertilizer program, when we throw in fungicides, we break the relationship of the trees with the soil. The amount of exudates that our trees are putting out with the spacing that we have, say a 12, 14, 15 foot spacing with a 19 or 20 foot row, it's just not enough to keep the soil microbial life happy in the soil or active. And so what you see is that when we apply a lot of nitrogen over the last 30 or 40 years, we burn through our soil organic matter. A lot of farmers that I talk to that I'm closely associated with and good friends with will say, I've been doing the same thing for 30 years. Now all of a sudden it's not working. And we're not talking about a 75-year-old pistachio tree. We're talking about something that should still be in the bulk of production, in the peak of production at 30 or 35-year-old pistachio. And my theory on that is that we had a certain amount of reserves in our soil organic matter, and when we're over applying nitrogen in lump sums during the year, we're burning through it, and so we're breaking the relationship of our trees with the soil over time. We are degrading our soils where we're losing cation exchange capacity, and so essentially what we've done is put our trees on life support.
So this last year was the first kind of our pilot program, so we did about 50 acres of it. So it has to incorporate animals. You have to have a cover crop, 20% reduction in nitrogen, and non-GMO seeds. So we did cotton planting, and it turned out pretty well. I mean, you typically saw 20% reduction in yield for your 20% reduction in fertilizer, but that's kind of how it worked out. So what we did is we planted a cover crop, and then we went from alfalfa to a cover crop. So when we sheeped off the alfalfa, went in later, planted a cover crop, then by the time it was cotton, we terminated the cover crop with a non-rounded up chemical, and then we go through and we planted directly into the ground. So it was only one pass, whereas with the strip till planter, and then we worked up the beds one time, and that's all it really was. And then you don't really have any more passes through. So it's all about reduction and keeping something green pretty much in the field year round.
As far as Sigma's effect on my ability to use cover crops, I'm absolutely concerned. I think we're going into a year where there's still a lot of questions about how our GSA is going to enforce Sigma on this. I know where my pumping levels are at. I think my goals are long-term, not necessarily short-term, and it's unfortunate that we're going into what's looking to become a very severe drought year. And the cover crops themselves are going to show a lot more benefit on a very wet year. And at the very worst, I think even out, according to my own records and my pumping on a dry year, but I'm not going to get the benefit of as much benefit of a cover crop as I am. So long-term in dealing with Sigma, I am really hoping that the GSAs will work with us and understand what we're doing long-term is going to provide benefits. There's a whole lot of programs. We've been in this situation before. You know, when we first started food safety, we had food safety auditors that were walking into our fields telling us to get rid of the owl boxes because they were saying that you're attracting birds into your field and they're gonna, you know, they're gonna defecate on your crop. And you know, we're saying at the same time you have animal rights activists that, you know, would disagree with that statement. And so we're kind of caught in the middle of saying, hey, we're trying to find new ways for integrated pest management, and there's some governing bodies that are pushing us the wrong way. And this, in my mind, is absolutely the wrong way. Cover crops need to be a part of any system and any grower that's willing to deal with them and deal with the challenges they bring. And I think long term, if you can keep them active, and I mean short term, forget long term. I think over a 1 or 2 year period, especially in wet years, you will see a huge benefits to cover crop. And the health, and ultimately what you're going to see is a big improvement in the health of your trees. And so even if in the short term, especially in a dry year, we only get 5 inches, I may end up a little bit in negative. For me, it's worth the investment long term because increase in soil organic matter, increase in the micro and macro pores, preventing soil erosion, habitat for pests, for my integrated pest management program in an organic field. If we're being told, you know, to eliminate every single green growing plant in our fields except for a tree, I think that pushes us in the wrong direction. It eliminates a whole host of tools. I can't improve soil health out here. I can't improve microbial activity unless I have a coat of armor on the soil and the trees don't cut it. I can't improve microbial health unless I have as many possible varieties of plant in this field, providing those root exudates to that microbial population as possible. If I lose the ability to plant a cover crop or have a soil armor, then everything else I'm doing as far as compost teas and tree health, it goes away. I might as well just go back to a perfectly conventional system. And I do think there are going to be some years where I end up in the red. It's hard to make the argument that these plants, instead of just being scorched earth down the middle, aren't pulling water. But on a wet year, I can guarantee you if I have 3% organic matter and my neighbor has a 0.5% organic matter, and I have a bunch of micro and macro pores in there, and I have worm activity, and I have a breakdown of the soils, and my water penetration is, say, 1 inch for every 10 minutes, and their water penetration is 1 inch an hour, and they have a ton of runoff, and mine is percolating in, long term, on the average, I can guarantee that my system is going to hold more water and use less water than someone else's. And that's what I'm going for. Not short term, not the first couple of years, what's going to happen long term. And so if you take away my ability to be able to do that and plant a cover crop short term, you take away my ability to improve the soil health long term.
Well, with the Sustainable Groundwater Management Act, we're going to run into a problem depending on your allocation, depending on your area, like how much water you have. Is it going to pencil out? Are you going to be able to farm your tomatoes, say, for instance, processing tomatoes and your cover crop? Are you going to be able to make that work? That's going to be the problem in the districts that are more restricted. Whereas in another district, say they're not as stringent on the pumping, it's going to be a little bit different. So it's all going to come down to what area you're in and if you can do the water. Pistachios and tree crops, it's in the winter. So you typically don't put water on in them anyway. But for the row crops, you really have to focus on, is the juice going to be worth the squeeze, I guess you'd say. It's alive. There's biodiversity throughout there. With Sigma kicking in and cutting off water, we're not going to be able to keep increasing our biodiversity. I mean, we want to do carbon capturing and all sorts of other things. But how are you going to do that if we don't have any water? It's just not going to work. I mean, if we can't pump water to do that, and we don't have surface water, you're not going to get that biodiversity, so it's just going to go back to what it was, almost 0% organic matter, like it was before we started all this.
One of this is the example in Sigma. So this is a temperature gun. I don't use this very often, but it's a good example if I'm talking to someone new or you know, a friend or a neighbor or something that I'm talking about my system. So the idea is that in a 100-degree day, 105-degree day, you might see bare soil along the roads or even on your berms in between the trees here. If it's full sun hitting that berm, you could see the soil heat up to somewhere around 140 degrees, 130, 140 degrees. Anything over 95 degrees, you're starting to kill off the microbial population or it's going dormant. Not only that, you're getting evaporation. As the top few inches of the soil dries up in direct sunlight, it's going to pull more moisture from down deep to equalize. It's actually going to pull more moisture and continue to evaporate. In some cases, when we're going to irrigate, if it's been 3 or 4 days and it's hot weather, we're actually having to rehydrate the top few inches of the soil in order to be able to push that water back down to where the roots are, 18 to 28 inches. And so in this system, when you have full ground cover and you're protecting that, yes, you are transpiring the soil surface. So the clover and the grasses that are transpiring are using up water, but at the same time, are they using more water than what you were evaporating when your soil was going up to 140 degrees? So right now it's about 65 degrees out, I would say. If you look underneath the soil, if I go underneath where the clover is and I use this gun in full sun, it is 71 degrees. So that's cooking in direct sunlight. If I go to green, where there's green on top, that's 66 degrees. That's actually dead cover crop. So it's only about 5 or 6 degrees more underneath the dead ground cover in direct sunlight. If you go to where it's actually under green roots and you look at the temperature of the soil there, 55 degrees. And I can see a bunch of activity down there, bugs breaking down. So it's actually about a 7, 8, 9, 10 degree difference below what the average temperature is. Now, if you come out here and you look in direct sunlight, where I don't have the ground cover, this is already at almost 90 degrees, 90, 91 right there. So what we have in a 65 degree day, we already have soil temperatures that are approaching the temperature where microbial life shuts down and starts to actually degrade. And so that's what we're dealing with here. And that's the argument against Sigma is we haven't done a good enough job measuring the water usage for evaporation versus transpiration and protecting our soil. So not only are we getting all these benefits and it's a home to the predator population in our integrated pest management programs, it's debatable on a wet year whether I can't store more water and lose less water in a normal year. And that's the question. So this is a pinchometer. It's a really helpful tool as you start your operation, especially if you're doing cover crops in the middle. It measures soil compaction, so it's got 2 heads on it. This is a larger head for a much looser, healthier soils. Obviously, I'm starting out in the beginning here with the smaller head. So it allows you to just put pressure on the soil where you have active growing roots and kind of look at the compaction. When I do that, if I were to do that anywhere, so this is still in the green, it's somewhere around, in the small head meter, it's somewhere right around 200 pounds of pressure. So that's right on the edge between yellow and red, between green and yellow. So it's decent compaction. When I get down to about 1 foot to 1.5 foot, I'll start to get into the yellow. Anything below 2 feet on most of the berms in this whole orchard is pretty highly compacted still. When I first started out, wet or not wet, it was immediately red in the top few inches. And so I'm starting to see progress there. That's the soil aggregates coming back, opening up the soils. You're starting to see I'm starting to see more respiration, which means that I can not only fix carbon, I can also fix nitrogen just with the soil respirating. And so what I'm doing is bringing in free nutrients, and I'm also creating a situation where my soil is hopefully not going to go anaerobic and create root issues eventually. This is the middle of the orchard where I do have some compaction issues. I am not even an inch in it. And obviously we've driven over this several times this year already, putting down compost seeds and whatever. So that's going to be an ongoing issue as part of my Healthy Soils program. I'm not allowed to till. Generally, I don't believe in tillage. That's one of the important parts of regenerative ag is you try not to disturb the soil. In this case, just on this strip in the middles where we're driving tractors across it quite a bit to put down foliars or foliar sprays, I'm going to have compaction here, and this is about what my berms look like. So I'm not even an inch underneath. I'm already in the red. I'm at over 300 pounds.
If I was going to get somebody started, or if somebody asked me a question from cover cropping, the first thing I would tell them is that we need to know what you're working with. That's the main thing. What type of seed are you going to use? Because that's the biggest thing. And when you're going to terminate it and how you're going to incorporate it. Because if you have all that planned out, the rest of it's going to be pretty simple.
I would say keep the cover crop, try to get it in 3 years in a row to start seeing the changes, because you will see changes in what grows well and your nitrogen credit and just the health of the tree as far as your water penetration along the berms. Even if you're not doing anything on the berms, just along the berms, seeing that increase in water penetration, opening up the soils, you'll see a big increase. And a big increase in the health of the trees is the bottom line, because you are going to increase microbial activity, so your miners are going to become more available to the trees, and you'll see a benefit over a couple seasons.
Well, in California cover cropping, I think that we need a little bit more research, because I mean we don't have the same growing conditions. We have 2 inches of rain in a week, whereas we're going to have to manually put on 2 inches of water. So if they had a little bit more research in our area, that would benefit everybody, I believe, and it would convince more people to actually do cover cropping. because a lot of people still think it's kind of like the Wild West with cover cropping. Because like I like to have, well, not even 10 years ago was I want a super clean field with no weeds, no nothing. Now it's like the whole opposite. We want to have something growing in there, have something moving, have the soil doing something rather than just being sterile.
So as far as, you know, how much of your orchards to start experimenting on, what I hear from researchers and agronomists that have advised me along the way is that you start with as big of a ranch as you're comfortable with financially. And that could, for some people, mean 5 acres, a couple of rows. It could mean 100 acres. You know, it really just depends on the size of your operation. But it is nice if you're not sure about what your goals are and why you're spending the money to have something to compare it to, especially when it comes to something like water penetration and if you have dendrometers or phytech or you have tensiometers in your field. It's nice to be able to compare the water usage, because there are a lot of the way we operate in ag is because someone told us something along the way and we took it as fact. And I hear those things all the time, you know. Organic production is naturally going to be a decrease in production. Well, that was the case 20 or 30 years ago when we didn't have the amount of organic products that we have now, or the measurement tools and things like that. So I think there's a lot of producers out there, cutting edge producers, that are producing more under organic systems than they were in conventional, and they're spending less money doing it. And so it's not a clear-cut road. There are challenges along the way, but I think it's possible. In general, I would say if we can reduce high salt fertilizers, even gypsum, generally the rule for us is not applying more than 100 pounds of salt annually per acre. That becomes very, very difficult if you have high calcium carbonates in our water. So we need to start with our water, and we need to acidify and treat our water somehow, whether that's sulfur burners or acid if you're not in an organic system. We need to make sure we stop salting up our soils. That's the first thing you need to do if you want to improve soil health. The second thing is to get it covered and active growing roots in as much of your orchard as possible for as long as possible during the year. And then the third thing is just try not to disturb it. That would mean tillage. That would also mean there's a lot of products out there for me that seem really good, but when you look at them and what they might do to the soil health, the soil microbial life, they're actually detrimental. So in using some of the tools we are to try and bring in the crop and keep our crop quality up, we're spinning our wheels. You're doing some things to improve soil health, but at the same time, some of what we're using, some of the chemicals we're using are either high salt or they're detrimental to the soil microbial life. So we need to eliminate as much of those as possible. And that is the challenge for all of us, myself included. I'm not willing to give up on any years of crop. I don't want to see high, crop damage. I don't want to see a reduction in my production. So it's a much slower process than letting this thing just kind of, you know, go through a natural succession and somewhat heal itself by whatever germinates out here. So the challenge is to try not to suppress microbial life while we're trying to bring in the crop. So, you know, I've run into that with zinc sulfate, you know, and boron are very high salt fertilizers. I have boron deficiencies out here. I need to use different chemistries that are a little more expensive. Spoon feed it, be very careful about how much I'm putting on at once. Things like that can make a big difference in your soil succession, your microbial activity. There's an ecosystem below our trees, and that ecosystem benefits us as farmers. And if we can push that ecosystem forward, bring it back to where it was, you know, let it flourish and work naturally, our trees are going to benefit. We're going to spend a lot less money, not only on pest prevention, pest control. Our fertility programs, we'll be able to reduce our fertility programs, and over time I think we're going to see a major increase in our water holding capacity and just a reduction in the pest pressure. So you know, we have to try to somehow, the key is how do we get from here to there, and that's the question.